One of the terms you're going to be hearing a lot about in the credential program is academic language. It's hard to teach your subject if the students don't have the academic language tools to be able to understand what you're talking about. And academic language includes many things. In terms of vocabulary, academic language includes a common vocabulary that's used in all disciplines, as well as a technical vocabulary that's inherent to each discipline. So one thing which is going to be an aspect of academic language is vocabulary. But it's only one aspect of this. You'll see that kind of a definition here is that academic language is the language needed by students to understand and communicate in the academic disciplines. So academic language includes such things as specialized vocabulary, but it also includes text structures within a field, essays, lab reports, and so forth, and other language-related activities common to typical classrooms. So in terms of science and mathematics, there's many things that you would concern yourself with in terms of academic language. I've written down a few of them right here. But what I want to focus on today is the development of graphs and figures and charts. And again, that's going to be part of the academic language of any discipline where you're going to be dealing with data and the interpretation of data. So we're going to be working, in this case right here, with spreadsheets. And we want to make sure that we can graph the data, in other words, pictorially represent the data that we want to show. So we're going to show how to do this using Microsoft Excel. You may choose to use other programs, but the key thing is that we are taking data and putting it in graphic form so it's easy to understand. So right here we see a chart that might be used in a biology classroom or a health classroom to talk about the causes of death in California in 2000. And it's quite interesting if you actually compare these causes versus the causes in a developing country. You'll see radically different profiles. So this can help you understand aspects of sociology and economics and many things. But right now we're just trying to talk about here in California in the year 2000. And it hasn't really changed that much since. So you can see that the major cause of death in California is heart attacks, then malignant neoplasms, which would be cancers, and then a lot of other different types of causes over here. Well, this data that you see graphed in this picture is coming from this table over here. So again, if we were trying to talk about the causes for death, like in a regular biology classroom, we might say, okay, well, heart attacks, #1 cause for death, and we can talk about plaque buildup and dietary things and so forth, and then start explaining the importance of this by actually graphing and showing that with a pie chart what the leading causes of death are. So when you want to plot data like this, it's important to represent it first in tabular form. So over here we have the table of the data right there. And now what we want to do is we want to graph that. Well, depending on your spreadsheet program that you're going to be using, there's going to be different ways to actually graph that information. And you're going to want to look under data and see some of those options. Now in my version right here, we don't see the charting tool under data, but you do see it here on the ribbon. So over here you'll see something that says chart, and you can see the different types of chart options. The one we're looking at right here is a pie chart. Now it's important to understand that there's different graphs for different purposes. Pie charts are to show the percentages of a whole. So for example, if we look at 100% of the deaths, okay, what percentage of those are caused by heart attacks? And in this case, we're going to choose a simple pie chart right here. And you can see very quickly that it plotted the data out simply because we had already selected the data when we chose the chart tool. Now in our situation here, we want to actually label the different sectors. And the ribbon tool makes it pretty easy because you can just go over here and look at the various different layouts. If we choose this one right here, you can see it actually gives the percentage values to the individual segments like that, and as well as the titles. So now it would be simply a matter of titling our chart, and we're done with this one. Now, when you have a chart like this, the default is to save it as an overlay within an existing worksheet. So this whole thing is the spreadsheet file, or sometimes called the workbook. And but there's different tabs. We're right now in the pie tab. If I click to column, you'll see that it has different data, and stat column has different data yet. We're in pie, and this is actually layering over on top of it. Now the advantage of this is that you can resize it and position it and so forth. Then if you get new data, let's say that malignant neoplasms, the actual data was supposed to be 80,000. Then when you do that, you can see that the graph will change corresponding to any changes that you see over here. So one of the reasons that you want to place it in the worksheet that you're working on is simply as you change numbers here, you can see the effect immediately on the graph. However, sometimes it's just too small to read, and particularly for projection purposes in class, it's going to be better to have it on its own separate sheet. So you can do that by right-clicking and saying, I'd like to move the chart, and you can move the chart to a new sheet. And so in this case, we could call this causes of death 2000, and now it's going to show up as a tab over here, and it's going to have be easier to see the detail. Again, if we reconfigure our table, this will be resized and so forth appropriately. So pie charts again are for representing percentages of a whole, and but they're not for comparing different things, and you'll see that in terms of some of our other ones. Okay, clicking at the tab at the bottom here, we're going to look at a column chart, another very simple way of representing data. If we were to look at our sunspots, a sunspot basically is a dark area on the solar disk. You can see there's one here, there's one here, there's one here, there's one here. And we've been watching these things over time to try to get an idea of what they mean. So here's some actual data that was collected at Mount Wilson here in Southern California of sunspot activity as a function of time. And if we wanted to say, okay, how do the number of sunspots vary as a function of time? Again, the idea here would be to first have our data in columnar form, okay, where we have the dates on this axis and we have the number of sunspots there. In this case, I'm going to highlight both the column headers because that's going to allow me to label the graph a little more easily. Having done that, we're going to click Charts. And again, if you have an older version, you may not see Charts right here. You may see Chart as a simple little icon up here. But we're going to choose Charts because this is going to allow us to see things a little bit more quickly. And we can look at the different types of columns that we can select from. So this is going to be just a straight plotting of the columns, and you'll see that there's an incredible variety here in terms of the ones to choose from. So if we were to choose one of these, like let's just say clustered column, we'll see our data, and our data will print up like this, but it looks a little odd, and you kind of go, what's going on here? I don't understand what the problem is. You can see what it's doing. It's assuming that the date column, the year column, is something to be compared against. So it's comparing sunspots versus year. Well, obviously, this is not a correct way to plot the data. So what instead we want to do is reconfigure the data so that we can plot exactly the height of the column will represent the number of sunspots, and the x-axis will represent the number of year, or the year. So what we're going to do is we're going to select just the column with sunspots, and we'll apply the x-axis variable or x-axis identification later on. So if we choose column right here, we'll still choose clustered column. We can see our data is looking correct, with the only exception or the only problem is that the x-axis is marking the year sequentially, not actually the date. So what we have to do is we have to be able to put the dates in here. So typically the way this is done is by looking at the chart and looking at the source data for the chart. In other words, where is the data getting the information from? So in this case right here, we can see that the charted data range, in other words, where it's actually getting the information, is from B2, which is right here at sunspots, to B12, which is right down here, the sunspot number for year 12. Now, that looks fine, but we don't have any x-axis labels. So you can see here the category x-axis labels is blank. So we can select this little icon here which says, okay, go ahead and select that off your table. And if I do that and then select the year, highlighting over here, and then go back and click that, it's now going to say, do you really want your x-axis labels to be from column A2 to column A12. The dollar sign just simply means an absolute value. In other words, always choose column A, always choose column row 2 to always use column A to always use row 12, which is what we want, because we want this data here, whatever we put in here, as we want it to appear as a label on this axis. That looks okay, we plot okay, and here's our data pretty much the way we want to see it. Now it looks good. We have a titled graph here. We need to change the, get rid of the key because that's pretty obvious. And then we need to label our axis on the y-axis over here. So again, going to chart and saying, okay, what do we want to have for our source data? We can click up on source data right here, and we can see that for our y values has indeed been chosen over here as the number of sunspots. We now just need to simply put a label onto that axis. So in our situation right here, we can get that y-axis by choosing the appropriate format. We're going to choose layout 5 right here, type on here and just say the number of sunspots. And so now we have a very interpretable graph, and if we want to, we can even format the background. Again, if you right click on a particular zone, you can see the different options. In this case, we can format the plot area because we're actually in that zone. So I'm going to say format the plot area, and I'll choose in this case a picture, and the picture I'm going to choose is going to be one from an actual picture of a sunspot, and this one looks like a good one. So having selected that, we're going to again say format the plot area, go ahead and choose the picture, select the picture, and then go ahead and pick the picture, and it'll pop it right in there to the background. So now we have a table here which has a lot of information. It shows the frequency of sunspots as a function of time, and could be pretty much interpreted by anybody who's interested in looking at this information. Okay, now we want to talk about a different type of a plot, what we refer to as a stacked plot. Here's a picture of the Paranoid Run at Mammoth Mountain. That's our sun racing down there. And to anybody who's interested in skiing, or more importantly, the water reserves in California, is going to be quite interested in the Sierra snowpack, a very critical feature for the state of California. And so here we have some data showing snowfall patterns at Mammoth Mountain, and we can see that we have them for October 1970, 1980, all the way to 2000. And then you can see the various different months. Well, snowfall changes quite a bit from season to season in terms of which months get the most, and so we want to look at a cumulative set of this data. So by highlighting the information we're looking at, in other words, from October to May, and from 1970s October snowfall down to May's 2000 snowfall. We can then choose a chart like a bar, and I'm going to choose a stacked bar here. All right, and so the stacked bar is going to come over here, and I'm going to enlarge that just to make it a little bit easier to see. Now, again, this is the same data as you're seeing over here, only it's plotted on a with its axes reversed. So everything looks pretty good here, except for we want to be able to graph all the data and like, for example, our series numbers there. So to change this to actual dates, we can go back up and again look at our source data and say, well, what does Series 1 say? Well, actually Series 1 is 1970. In other words, that's the first series of data. Series 2 is 1980, Series 3, 1990, and so forth. So now, by going through and actually defining our values, when it plots out here, you'll see that the colors now correspond to the years. So we've made the data, the chart a little bit more interpretable. Now, if you want the actual values to show, again, you could choose the option which plots that data, and then again give the title, you know, again in meaningful terms. So this is going to be the snowfall at Mammoth, and that's going to be 1970 to 2000, at least on 10-year intervals. So now we have a finished table that shows the snowfall patterns. And again, what's interesting about this is you can see that it does change dramatically. Obviously, the year 1990 was a relatively low snowfall year. In fact, in December of 1990, hardly any snow fell. In fact, I remember that very well. I was up there at Mammoth in the end of December, and there was hardly any snow there. But then it made it up for it dramatically. Actually, not that year, but the next year, in 2000, December had a huge amount of snowfall. So again, the key thing here is to know which kind of graph do we need for what kind of data. And this is a stacked plot which shows the cumulative value. In other words, here's the cumulative snowfall over those 4 years in January, and versus the cumulative snowpack over 4 years in December. And then we can compare the individual years based upon their colors. Now, how about if we want to plot information from different columns that aren't adjacent to each other? Here's a data table over here which shows the abundance of some different elements in like the universe and the sun and in humans. And so let's look at these. Let's just compare the abundance of elements in two different sources here. For example, we want to compare the abundance of oxygen, iron, silicon, and these different elements in the Earth versus the Earth's crust. So if we're to look at the structure of the Earth, you can see that the crust is just this very tiny layer on the outside, almost like the peel of an apple relative to the rest of the apple. We want to see, is there any difference between the abundance of the elements in the crust versus the Earth as a whole. So to do that, we want to plot the information in this column versus the information in this column. But since they're not next to each other, how do we do that? Well, it's actually fairly easy. You select the column that you're interested in. In this case here, I'll select with the element names and so forth in place. And then by holding down the Command key on the Mac, and it'll be the Control key generally on the PC, we're actually highlighting two things that are not next to each other. So it allows you to do comparisons where they're not right adjacent to one another. Let's go ahead and choose the bar diagram. And we can use a clustered bar because now we're clustering them based upon comparing with the two of the same things. So here's the chart, and we can now see the abundance of the elements in the Earth's crust versus the Earth as a whole. And it again highlights certain things like that that in the Earth, nickel is fairly abundant, but it's actually pretty rare in the Earth's crust when you see that the red line there hardly shows at all there. Now we can title this over here, and again, by just selecting this up here, we can say that we want the relative abundance of elements. Okay, and so obviously we're now comparing the Earth's crust versus the Earth. Now perhaps the most important plot type is the XY or scatter plot. And so I'm just going to click on the XY scatter plot. And here we have data that shows the atmospheric concentration of ozone in the atmosphere here in Los Angeles over a 24-hour period. And we're comparing 3 different places at the beach, like over at Santa Monica Beach, in the mountains, that would be like Mount Wilson, in the valley right here in the San Fernando or San Gabriel valleys. We want to be able to plot this information. So this is a scatter plot, and scatter plots allow you to plot whenever your x-axis, in this case time, is variable. In other words, that the intervals between the times at which the data is taken don't have to be the same. Now in this case they are, okay, each thing is a 1-hour interval, but they could represent any axis. So for example, this could be like pH, okay, the concentration of acidity. And you wouldn't have to have even intervals to be able to collect the data. So most scientific experiments, the x-axis is not constant interval, and therefore you'd want to use an XY scatter plot. So all the people in the sciences, this is the most valuable one for the teaching of the sciences. So we're going to highlight the 3 columns we're interested in, and again using the chart layout features right here, we're going to say that we'd like to have this as a scatter plot, which is oftentimes known as an XY plot or XY scattered. We're going to connect the dots in this case just to make it a little bit easier to distinguish. And there we go, we have the graph in its basic form. And as before, it simply is a matter at this point in terms of adding the specific labels in terms of the titles and so forth. So if you choose up here, you can click on this axis, which is now, or this option, which is going to give you a chart title, which you can go ahead and apply. And then of course you could give the y-axis and so forth as well, just simply by double clicking on it and typing in the value as desired. So now we have shown how to do an XY scatter plot. And just again to review, we can take this graph here. If I right click on it, I can see all the various options I can use on this particular table. And so what I want to do in this case, I'm going to move this to a new sheet so it's a little bit easier to see. So I'm going to move this to its own sheet. We'll call this ozone. Now it's on its own sheet, and let's say we wanted to add some kind of color to the background. In this case, maybe a picture of the smog here in Los Angeles. So if I want to add a picture to the background, I would right click on the background itself, and then I'd say format the plot area. And if I had already selected a picture to work from, which I'm going to choose right here, this is a I'm going to select a picture of the air pollution in Southern California. This was taken while mountain biking through the Santa Monicas, and you can see the inversion layer here, and this is all Los Angeles underneath, and of course the clear blue sky above. So if I want to put this picture in, I need to simply select that and put it into that area. So there it is. Click on there and insert. Now that picture goes into the background, but it makes it a little bit hard to see the text. So I may want to change the transparency, and I can do this right in the same menu here just by adjusting the slider right here until I get a value that looks pretty good. If I want to get rid of some of the grid lines, I can simply just double click on the grid lines. I could change their color and so forth, or I could hit the delete key and just make it easier to see the background. So again, another way to represent the data pictorially. And this is the XY scatter plots are extremely useful again for any kind of scientific plotting, any kind of time situation where you don't have even interval on the x-axis values. So hopefully you've seen from these few examples there's lots of different ways to represent and graph the data. You want to make sure that when you choose your data that you're graphing it correctly. In other words, it makes sense. So for case if you're using stuff which is just representing percentages, you could choose a pie chart. If you're representing things which are even intervals like this, you could use a column, or this could be also just discretely different topics. Like these could be like values for different entities, like different states or different counties. Information which may be collectively wanted to be analyzed using a stacked column. You could do clustered bar charts when you're trying to compare two different things, like in this case the Earth's crust versus the Earth in terms of the relative abundance of the elements. Or XY scatter plots when you're looking at an independent variable, I should say the change in a dependent variable, like in this case the parts per million ozone is a function of an independent variable, as in the case of time. You can always configure your graphs. You want to make sure they have a clear title, clearly labeled x-axis and y-axis. So in this case here I would need to correct this by simply adding the hour of the day. And then you can configure any chart and graph in a lot of other ways simply by clicking on the item you're interested in, like in this case the values there, and then selecting different options and so forth up here. So you can go ahead and play with that until you get exactly the display that you desire. So create two graphs of your own choosing. You're going to want to make sure that you first have some data to work with and put it in a graphic form, in a tabular form like that, and then create the graph based upon that table of data for two things relevant as possible to your curriculum.